Good morning, students. Let us start our today's class. Now we will take a small break from current electricity and we'll come back to light. And today I am going to start a new chapter, that is chapter 11, the human eye and the colorful world. But as you know, the human eye part is excluded from your syllabus, that is page number 187 to 190 are excluded from the syllabus of your board exam. So we will start from refraction of light through prism. Now what is prism? Prism is a homogeneous transparent refracting medium bounded by at least two non-parallel surfaces inclined at some angle. Now look at the picture of the prism I have drawn here. A is the angle of prism or refracting angle, and the shaded part, two faces are there. These are the refracting surface of the prism. Now let us discuss what is dispersion of white light by a glass prism. When white light passes through a glass prism, we get a band of 7 colors on a white screen. And the colors obtained on the screen are violet, indigo, blue, green, yellow, orange and red. That is vividure. So we can conclude that white light is a mixture of 7 colors. And the phenomena of splitting of white light into 7 colors is known as dispersion of light. So what is the definition of dispersion of light? The phenomena of splitting white light into 7 colors when it passes through a glass prism is called dispersion of white light. And the band of 7 colors of white light is known as spectrum. Now here I would like to inform you that the dispersion of white light was investigated by famous scientist Sir Isaac Newton. Now let us discuss what is the cause of dispersion. First, observe the least of the wavelength of color what I have given here. Here see, wavelength of red is 7900 angstrom, orange is 6000 angstrom, yellow is 5800 angstrom, that of green is 5400 angstrom, wavelength of blue is 4800 angstrom, indigo is 4500 angstrom, and the wavelength of violet is 4000 angstrom, where 1 angstrom is equals to 10 to the power minus 10 meter. So white light consists of 7 colors and each color has its own wavelength. Look the least carefully. Wavelength of red is the longest one and wavelength of violet is the shortest one. Now we know the speed of light depends upon the wavelength of the color of light. As V equals to n lambda, from this relation we can conclude velocity of red is greater than velocity of violet, and also velocity of red is maximum and velocity of violet is minimum. Thus each color of light travels with different speeds in a given medium, and hence all colors of white light are refracted by different amounts while passing through the glass prism. And also we know refractive index mu is equals to C by V equals to sin I by sin R. Therefore, when a white light passes through a glass prism, different constituent colors come out of the prism at different angles. And here mu red is less than mu violet, and this gives rise to the dispersion of white light. Now let us discuss some practical examples of dispersion of light in nature. And rainbow is the most interesting example of dispersion of light. When sunlight falls on a water droplet suspended in air, the sunlight is refracted through the water droplet, and the refracted sunlight splits into its constituent colors. And these water droplets suspended in air behaves as a glass prism, and the red color deviates the least and the violet color deviates the most. Different colors of refracted sunlight falls on the opposite face of the water drop and suffers internal reflection. And the reflected colors on reaching the lower surface of water droplet are refracted again into the air. And thus we get the spectrum of 7 colors, which is known as a rainbow. Now, to explain rainbow, I have used one term, total internal reflection. So, what is total internal reflection? Actually, it is not a phenomenon of reflection. It is a particular situation of refraction of light. And we know when light passes from denser to rarer medium, it's bent away from the normal. See here in the first picture, green light. First situation is green light, which is passing from the denser to rarer medium, and here refracted angle is more than the incident angle. Now observe the blue light. Here I have increased the incident angle, and obviously refracted angle also have increased. So if we increase the incident angle, slowly refracted angle will also be increased. Now observe the second diagram. We will get a particular situation for a particular incident angle where refracted angle will become 90 degree. So for a particular incident angle, refracted ray will pass through the interface of the two medium, of the rarer and the denser medium. Okay. So that particular incident angle is known as the critical angle. So if we increase the incident angle more than the critical angle, automatically the refracted angle will be increased and it will be more than 90 degree. So what will happen here? While light passing through a denser to rarer medium, and if the incident angle is more than critical angle, and refracted angle is more than 90 degree, the refracted ray will come back to the first medium. Now just recall what is reflection. In reflection, light passing through a particular medium and it bounces back from a opaque medium, come back to the first medium. Okay. So here also light is passing through a particular medium and again come back to the same medium. But what is the difference between reflection? For reflection, light reflects back from the opaque medium. But here, reflection is not happening. This is a particular situation of refraction of light. But like reflection, the light is coming back to the same medium. Okay. So, that's why the reflection term is used here. But why total internal reflection terms is used? In reflection, a fraction of light is absorbed by the refracting surface. But here, the total amount of light is come back to the first medium. Not a single part will be absorbed by the second medium. That's why this is known as total internal reflection. So this is a particular situation of refraction of light, which is known as total internal reflection. Now refraction of light through diamond and mirrors in vases are the good examples of total internal reflection of light. Now this much is for today's class. Thank you.